On the topic of trig substitution, suppose I ask you to evaluate the integral of dx divided by x squared times square root of x squared plus 4. Okay, how to deal with these types of integrals? We're going to use a trig substitution. This guy can be written as the integral of dx divided by x squared plus, not plus, let me just erase this, times the x squared plus 2 to power 2. Okay, so what substitution help here is u equals to, or x equals to 2 tangent of theta. Why is that? Because you can simplify your denominator. X squared is equal to 4 tangent squared of theta. And if you take dx, let me write down dx with a different color. Dx is equal to 2 times secant squared of theta d theta. So let us try to simplify this as well. And remember that since x is equal to 2 tangent theta is x divided by 2. So if you go back to a right triangle here, by the definition of tangent of theta, tangent is sine over cosine. This is x divided by 2. By Pythagorean theorem, this length is x squared plus 4. So remember these steps. We're going to use these and eventually convert this from x to theta, from theta eventually to x. Very good. So take a look. This can be written as the integral of dx. Well, I calculated dx. dx is 2 secant squared of theta d theta. On the denominator, I have x squared. What is x? X is 2 tangent theta. So let us copy this guy down on the denominator, 2 tangent theta, which raised to the second power, times square root of, well, I have x squared. Again, x squared, you have 2 tangent theta to the second power plus 4. Okay, let's see what we can do then. Here you have the integral of 2 secant squared of theta d theta divided by 4 times, let me use the same color, 4 times tangent squared of theta, and then down here inside the radical, you get 4 tangent squared of theta plus 4. Very well. Here you can factor out 4 and simplify this guy further. You get the integral of 2 secant squared of theta d theta divided by 4 tangent squared of theta, and then inside here you get the square root of 4 times 1 plus tangent squared of theta. Let us close up the parenthesis. Okay, very well. This integral can be written as the integral of, just copy down everything to make sure you can follow all the algebra, all the simplification here, divided by 4 tangent squared of theta, and then you get 2 times square root of 1 plus tangent squared. But the square root of 1 plus tangent squared is the square root of secant squared. So this guy can be simplified as, you can get rid of 2 and 2. Why not simplify this on the way? You get the integral of secant squared theta d theta divided by 4 times tangent squared of theta times the square root of secant squared. Okay, now I see some hope. Very good. This is the integral of secant squared of theta d theta divided by 4 times tangent of theta multiplied by itself. So you have tangent squared, and then you have square root of secant squared, which is secant of theta. Well, of course, we can cancel out secant and secant squared. This in turns can be written as the integral of secant theta d theta divided by 4 times tangent squared of theta. Now, how to deal with this integral? This integral is equal to, remember the definition of secant, remember the definition of tangent. This can be broken down into the integral of, on the numerator, the secant is 1 over cosine theta d theta. On the denominator, here you have 4 times tangent squared, which is secant squared. Let me write sine. We need sine. So you have sine squared of theta divided by cosine squared of theta. But again, please pay attention. 1 cosine and the exponent, they get canceled out. So this guy can be written as 1/4 the integral of cosine theta d theta divided by sine squared theta. Cosine theta d theta divided by sine squared theta. And this is a simple u sub for you. Take u to be sine theta. du is cosine theta d theta. So this integral in turns can be written as 1/4 integral of du divided by u squared, which is 1/4 times -1 divided by u plus constant of integration, or in turns, it can be written as -1 over 4u plus c. But what is u? Right? U is sine theta. There is no doubt here. But what's the relation between x? This is -1 divided by 4 times sine theta plus constant of integration. But we are not done yet. Go back to the question top. Here you have the integral of dx divided by x squared times square root of x squared plus 4. Well, we need to get rid of sine theta on the denominator. What is sine theta? So let us go back to our right triangle and see what do we have for our sine. You can also write this guy as cosecant if it makes it easier for you. So -1/4 cosecant of theta plus c. So we are going back to the right triangle that we had, 2x and square root of x squared plus 4. My triangle, right triangle, what I had 2x, and this was my theta, and this length is hypotenuse, which is x squared plus 4. So if I ask you to calculate or to write cosecant of theta, remember that cosecant of theta, which is 1 over sine theta, this is r divided by the length x, right? So what do we have here? What is r? R is the square root of x squared plus 4, and on the denominator you have x. So this integral is equal to negative a fourth square root of x squared plus 4 divided by x plus constant of integration. Using the method of trig substitution to calculate the integral here. So I have x, just want to make sure we highlight everything correctly. And here you have all the steps to check